Hello, my name is Dobrowolski, and today I will be discussing the gender gap in introductory physics courses at McMaster University. This research was carried out under the supervision of Dr. Pat Clancy and Dr. Miranda Schmidt. Through multiple studies, it is seen that male undergraduate students perform better than female undergraduate students on force concept inventories, leading researchers to believe that male students perform better than female students on physics tests. The cause of this gender gap is undetermined, but it is believed to be somewhat caused by factors such as test anxiety, student belief in their ability to succeed, and differences in self-efficacy. This study was an attempt to analyze these results at the local McMaster University level, to see what kind of gender gaps exist in these internalized factors. The two factors specifically analyzed are quite broad, with student interest and preparedness for their upcoming course. In the interest of accessibility, I have transferred my poster sections into slides to make it easier to read and follow along on a computer screen. This survey was distributed to 3 introductory physics cohorts at McMaster, with the course list as follows: Physics 1 AO3, Physics 1 CO3, and Physics 1 DO3. The amount of respondents by their gender is listed beside the course. The sample size of approximately 10% of the student population was gathered, with students being asked to complete the survey through email and through Avenue to Learn, and the results were gathered from volunteers. Now, 4%, it is important to recognize that 4% of the responses were from students who identify as genders that are not male or female, and while their experiences are important here at McMaster, the results were not included due to the high variance that they would have. First, to take a look at the interest. Interest between courses varied noticeably, with 1 CO3 and 1 DO3, the courses more closely associated with physics and engineering, having higher interest than 1 AO3, the course usually associated with life sciences. A significant gender gap is only present in 1 AO3 across both 2020 and 2021. 1 CO3 has an absolute gender gap in 2021, but the low sample size means that results cannot be interpreted as significant. 1 DO3 did not have a significant gender gap. Next, student self-reported preparedness. 1 AO3 has a preparedness gap across both surveyed years, though lowering a bit in 2021, while, interestingly, 1 DO3 only had a preparedness gap in 2021, which wasn't present in 2020. Male preparedness stayed almost identical across the 2 years, while female preparedness significantly dropped. 1 CO3 also has an absolute preparedness gap. However, this cannot be interpreted as significant, again due to the low sample size and high variance of these results. In order to analyze these gaps, a new question was asked in 2021 to see whether any very large gaps in grade expectations form. This question asked students to bin their expected grade between 70 to 80, 80 to 90, 90 to 100, etc. For analysis, the lowest number of this bin was taken. The results indicate that it is worth pursuing this question deeper, likely with smaller bins, because even with these very large bins, a gender gap appeared in 1 DO3 of 3%, which is quite large considering that these bins cover 10% ranges. 1 CO3 also has a relatively large gap, but again, the variance and the sample size make it hard to determine its significance. So, how can this be addressed? First, it is important to identify that this gap might be forming as early as ages 12 and 13, with a study by Microsoft indicating young girls were already losing interest in STEM by this age, while a UK study showed that high school girls were much less likely to put STEM as their best subject and instead gravitated towards humanities and English. Thus, the gap might be forming far before these students have even arrived at university. The best way to address this in the short term is by using outreach programs to keep girls interested and confident in STEM, as girls who had positive encouragement were more likely to enroll in classes than girls who had no encouragement or regular societal encouragement. In the long term, these outreach programs can increase university enrollment, and in doing so help increase the diversity of these quote-unquote male-dominated fields. This may help combat negative and sexist stereotypes like males have more science-oriented brains, and increase confidence and comfort of females in this field. If you are interested in viewing the posters so you can take a look around the references and the charts at more depths, please send me an email at this link and I will be glad to forward it to you.